Hi, good evening. My name is Antonio Caldwell, and we will be reviewing today correlational analysis. Our proposed agenda for today, we will review 6 correlation tests: income and stocks, income and savings, income and wallet, savings and stocks, savings and wallet, stocks and wallet. We'll then review a few key takeaways, and then I'll open it up for questions. Our first hypothesis test, the following correlational test was conducted. The null hypothesis, there is no correlation between the income and stocks amount. Our alternate hypothesis, there is a correlation between the income and stocks amount. The correlation coefficient and its p-value were calculated using PPT, assuming that alpha equals 0.05. A significant correlation emerged. The coefficient 0.19 and the p-value equaling 0.018. The test rejected the null hypothesis and concluded that there was a correlation between the income and stocks amount. Our second hypothesis test. Null hypothesis, there is a correlation between the income and savings amount. Alternate hypothesis, there is a correlation between the income and savings amount. The correlation coefficient and its p-value were calculated using PSPP, assuming that alpha equals 0.05. A significant correlation emerged. The coefficient of 0.91 and the p-value equaling 0.0. With those values, the test rejected the null hypothesis and concluded that there was a correlation between income and savings amount. Our third hypothesis test, the null hypothesis was that there is no correlation between the income and wallet amounts. Alternate hypothesis stated that there is a correlation between the income and wallet amounts. The coefficient equaling 1.0 and the p-value equaling 0 stated that the test rejected the null hypothesis and concluded that there was a correlation between the income and wallet amounts. For our fourth hypothesis test, the null hypothesis was created. There is no correlation between the savings and stocks amount. Alternate hypothesis, there is a correlation between the savings and stock amount. The correlation coefficient and its p-value were calculated using PSPP, assuming that alpha equals 0.05. A significant correlation did emerge with the coefficient of 0.28 and the p-value equaling 0. The test rejected the null hypothesis and concluded that there was a correlation between the savings and stocks amount. Our fifth hypothesis, for savings and wallet, there is no correlation between the savings and wallet amount was a null hypothesis. The alternate hypothesis stated that there is a correlation between the savings and wallet amount. The correlation coefficient and its p-value were calculated using PSPP, assuming that alpha equals 0.05. A significant correlation emerged from the coefficient of 0.19 and the p-value of 0.017. The test rejected, and the null hypothesis concluded that there was a correlation between the savings and wallet amount. Our sixth and final test, the hypothesis for the stocks and wallet. The null hypothesis dictated that there is no correlation between the stocks and wallet amounts. Alternate hypothesis, there is a correlation between the stocks and wallet amount. The correlation coefficient is the p-value were calculated using PSPP, assuming that alpha equals 0.05. A significant correlation emerged with the coefficient equaling 0.19 and the p-value equaling 0.017. we could reject the null hypothesis and conclude that there was a correlation between the stocks and wallet amounts. Some of our key takeaways: correlation analysis is useful when there is a need to establish if there are possible connections between variables. The value of R is always between -1, which is a strong negative relationship, and +1, dictating that there is a strong positive relationship. And lastly, correlation coefficient values less than 0.8 and greater than -0.8 are not considered significant. Thank you very much, and I go ahead and open it now for any questions.